Hello everyone, today we are going to discuss about pulse amplitude modulation. This is coming under analog pulse modulation technique. So three different analog pulse modulation techniques are available: pulse amplitude modulation, pulse width modulation and pulse position modulation. In this video we are going to discuss about pulse amplitude modulation. So in the pulse amplitude modulation, the amplitude of the pulse is varied with respect to the instantaneous amplitude of the message signal. So the first signal representing the message signal, the second one is a carrier signal. So in this carrier signal we are using the square wave or your corresponding pulsed signal. So the pulsed signal act as a carrier signal. Generally in amplitude modulation, the sine wave will be act as a carrier signal. So what is the main difference between pulse amplitude modulation and amplitude modulation means? Here the message signal there is no difference, the carrier signal only the difference. Here we are using pulsed signal. In the amplitude modulation we are utilized sine wave. So when we are going to perform pulse amplitude modulation, amplitude of the pulsed carrier signal is varied with respect to the message signal. So the third signal representing PAM signal, pulse amplitude modulated signal. In this modulation, width and position of the pulse are constant. So with each and every pulse width and also the position after modulation also it is constant. The two types of PAM signals are available. One is natural PAM, another one is flat top PAM. In the natural PAM, the top of the pulse, the corresponding shape will be identical or similar to the shape of the modulating signal. Here in the flat top sampling, the top of the pulse will be flat. Now we are going to generate how to generate the flat top sampling or flat top PAM signal. In the generation of PAM, we are utilizing this corresponding simple circuit diagram to generate a pulse amplitude modulated signal. There are two different transistor, field effect transistor 1 and 2 utilized here, and also the capacitor is connected parallel to the field effect transistor. So the similar circuit here we are represented. Both the field effect transistors are act as a switch 1 and switch 2. So now we are going to apply a message signal here. So in that particular time instant, if you are applying the clock signal or pulsed clock signal to the field effect transistor 1, it will be act as a switch. Now it will goes to on condition. Once it is closed, the message signal is sampled during this pulse duration. The corresponding capacitor will charge the voltage up to message signal amplitude. So we will get a first sampled signal or pulse amplitude modulated signal. So once you are getting the first sample or first pulse, then again we are applying the clock signal to the switch 2. Now in this situation, switch 1 is open and switch 2 is closed. So once switch 2 is closed, the capacitor will completely discharge through the ground and it will goes to zero condition. Then you will get this corresponding position in the pulse amplitude modulation, that is called your off period. Similar manner, when you are going to apply a second pulse to the field effect transistor 1, then switch 1 will be closed and switch 2 will be open. You will get a second sample. So after getting a second sample, again we are going to open switch 1 and close the switch 2 and completely discharge the capacitor. When you are going to do like this by applying the clock signals to the switch 1 and switch 2, we are able to get a pulse amplitude modulated signal. So this pulse amplitude modulated signal is transmitted and received. By using the demodulator, we are able to deduct the original message signal by using sample and hold circuit and low pass filter. In the sample and hold circuit, this is a very simple circuit diagram utilized, will act as a sample and hold circuit. When we are applying this sampled signal or pulse amplitude modulated signal to the sample and hold circuit, when the switch is closed, the first pulse entered into this particular circuit, and capacitor will charge up to this particular level, whatever based upon the first sample amplitude. Up to that maximum level it will charge. Then after charging the capacitor, there is a gap between two adjacent pulses. During that off period, the charge will be maintained as it is. Then the second pulse will appear across the capacitor. It will develop a voltage and extend the charges up to second pulse. Similar manner, if you are applying the third pulse, it will develop a voltage. So finally, it will follow the entire PAM signal and will generate a like your step signal. So this step signal is actually not our message signal. By performing the smoothing operation or eliminating the ripples in this corresponding signal, we can get a exact sine wave. So that operation will be performed by using low pass filter. So this low pass filter used to eliminate all the ripples or sudden variations in the signal. Then finally you will get a nice sine wave as like message signal. This is the demodulation process of pulse amplitude modulated signal. So if you want to transmit this corresponding pulse amplitude modulated signal, the bandwidth requirement is represented here. One sample pulse amplitude modulated signal. So the on period time duration is T and another off period time duration is another T. So T plus T 2T. So 1 by 2T is the maximum frequency of the signal. In this corresponding condition, the minimum bandwidth requirement equal to, so you are greater than or equal to 1 by 2T or greater than FM. So this is the bandwidth requirement for pulse amplitude modulated signal. There is advantages and disadvantages of PAM. Advantages, obviously it is a simple process for modulation and demodulation. Transmission and reception circuits are simple and easy to construct. Disadvantages of PAM. In PAM, noise cannot be removed easily because we are performing the amplitude modulation or amplitude variation. So then we are unable to separate whether this amplitude variation because of noise or message. So the transmission bandwidth requirement is too large compared with analog modulation technique. The transmission power is not constant because we are performing the amplitude modulation. So each and every pulse's amplitude will be varied based upon the message signal. Thank you for watching this video. In the next video, we will discuss about pulse position modulation. Thank you.